What's up, everybody? I have in front of me here your 4 homework problems for tonight. There's the fourth. So what I'm going to do is on this video is help you out with it, but I'm not going to do these 4 problems. I'm going to do do 2 of the problems that we did in class today. All right. I'll do one that will help you with number 1, and then the second one I do should help you with the rest of them. All right, so let me go back to what we did in class today, and here it is. These are the 7 problems we did in class. I'll do number 1. So I have my steps right here. I'm just going to follow those. So the first step is to break it apart. Break apart this radical. Got radical 25. That's a 2. Please forgive me. And radical x squared. So it's very important that when you break them apart, you have to keep the radical, right? So I'm not just writing x squared by itself. I can't put it by itself yet. Everything has a radical. So now the whole purpose of this video is to figure out what numbers we can take outside of the radical and what numbers we need to leave inside of the radical. So we're just going to do some simple math to figure out what can come out and what needs to stay in. So in the beginning, everybody is still under the radical. Nobody has come out yet. So let's start here. We know this one, square root of 25 is just 5. And we can't do anything with this yet, so let's go to step 2. Step 2 is to divide the exponent by the index. So 2 is your exponent because it's x squared. Here, your index is going to be 2. Your index is always that small number outside of the radical. It could be a 3, a 4, a 5, or anything. But if you don't see a number, then you got to assume that it's 2. All right, matter of fact, it's going to always be 2 if you don't see a number. The reason why is because it's a square root, and anything squared always goes with 2. Just like x squared is x to the second power, a square root always has an index of 2. That always just goes together. Won't get into exactly why that is, just not on this video. That's a whole nother subject, but it deals with area and lim times width and 2 dimensions. But anyway, moving on. So let's go ahead and divide this now that we know what our index is. So again, the index is going to always be 2. 2 divided by 2 is 1. So 2 divided by 2 is 1. So we're going to write x to the first power. And really, you don't even need that 1. But for the sake of your learning, you can write it. It's not wrong. All right, so now we're going to circle our answer. We are done. And on this particular problem, we were able to get rid of that radical completely. We don't really like radicals like that because they represent irrational numbers. And irrational numbers aren't really cool to work with because they aren't exact. So most times we try to get rid of the radicals as much as possible to really simplify this problem down. So we simplified this down to just 5x. So we're done. Easy, right? Let's jump to number 7 where it gets a little bit more difficult. I'm going to go down here to number 7 because I don't think we got to this in class today. So let me bring down my steps. Hold on, y'all, bear with me. Let me get my steps. Bring my steps down so I remember what to do. I don't want to mess anything up. And there we go. Scroll a little bit more. All right, there they are. So again, step 1, let's break this whole thing apart and see what can be canceled out, what can come outside of the radical, and what needs to stay in. So step 1, break it apart. So we got radical 60 and square root 60, same thing. Sometimes I say square root 60, sometimes I say radical 60, same thing. Times r to the third power, he gets a radical. Keep up with the radicals, people, super important. All that's under radical. And we've got s to the second power. That's going to go under radical. So we got s to the second power, and then t to the fourth power. T to the fourth. There we go. And all of that stays up under a radical. And yeah, all of that stays up under the radical. Now, let's go to step 2 to see what we can cancel out. All right, so the square root of 60, this is not a perfect square. So we got to break it apart to see what can come out. Now, we're not going to use 10 times 6. The reason why is because we don't know the square root of 10 and we don't know the square root of 6. So we got to use one that we do know. All right, so we can use square root 4. We know that. And let's use square root 15. Yeah, 15 times 4 does equal 60. So that's good. We'll use that. And we can break this down to 2, because square root of 4 is 2, and we're going to bring down the radical 15. We've taken care of that term. All right, we've taken care of this. Let's go here. To do this, we got to divide exponent by index. So exponent by index, I'm going to write that up here. We got to do these division problems. I'm going to do one for R, one for S, and one for T. So there's R, there's S, and there is T. So just set up the simple division problem, people. What do we divide? We divide the exponent divided by the index. Well, you know the index on all of these is going to be 2. So you're going to divide by 2 on all of them. That is a 2. Please forgive me. I'm trying to do this with the mouse. All right, so that is a 2. Now, we're going to do 3 divided by 2 for the R. So we got 2 and we got 3 there. And then S, we're going to do 2 divided by 2. Well, that's just 1, so I can go ahead and skip ahead on that. So that's just S to the first power, because 2 divided by 2 is 1. Same thing here. This is just going to be 4 divided by 2. That's also easy. That's just 2. So we're going to write T to the second power. Notice there are no radicals here. This is important on this S and that T, because when we try to reassemble it, we got to figure out what's going to go on the outside of the radical and what has to stay inside. Here, we know all of these are outside. We have completely gotten rid of the radical. Yeah, but something's funny going to happen with this R. So let's go ahead and divide it. So we got 2 divided by 3. Oh, I'm sorry, 3 divided by 2. 1, simple division here. And my remainder is 1. See that? That's easy math. Here's what this means. When you divide it, the quotient, the answer, right? That goes outside the radical. That's important. So when you're doing your homework and you're dividing this, you got to know what that means. The 1 goes outside. The remainder remains inside. The remainder remains in the radical. That's the way I like to remember it. The remainder remains inside. So he's going to stay inside. Now, how do you write that? All right, Mr. Williams, I get it. 1 goes out, 1 stays in. What does that mean? That means you're going to put 1 R outside of the radical, and you're going to put 1 R inside the radical. So you got R, radical R, just like that. If you divide it, say you have an exponent of 5. Like, look at this problem right here on number 4. See that? This is where I am. Now, I'm not going to do this whole thing. I'm just going to show you something. We got to divide that B. If we were to do B, all right, and we got 5 divided by 2, right? So let me put my 2 there, like that. This is simple division. We all know this. 2 minus 4 is 1. Now, on this one, you would put 2 B's outside the radical and 1 B inside. So that would be written as B to the second power radical B, right? That's how you would do that. But this one is more simple. You only got 1 outside and 1 inside, because your quotient is 1, your remainder is 1, 1 outside, 1 inside. Good. So we've taken care of the R. We've already done the S. We've already done the T. We've taken care of this square root 60. We've taken care of everything we broke up. Now let's reassemble like the Avengers or like the Transformers. All right, so we got to hurry up. Got like 30 seconds left. All right, so let's just do it. What goes outside? The 2, the R, the S, and 2 T's. So I got 2 R S T squared. All of that is outside. What goes inside? The 15 and the R. So I write 15 R. This would be my answer. Good luck on the homework. Email me for questions.